How do you handle runtime errors without a mess of try-catch and if-else statements? Let's see how higher order functions and composition can help on today's episode of TLDR, the JavaScript Codecast series that teaches working web developers to craft exceptional software in 5 minutes a week. Last episode, we saw how custom errors can often make our code worse, but custom exceptions can help by allowing intermediary functions to focus only on the feature's happy path. If you're just now joining us, hop back to the previous episode on custom exceptions. Exceptions are useful when they eliminate if-else statements from calling functions, but at some point an exception needs to be caught and handled, and that's where the try-catch statement tends to make a mess of things. Today, we're continuing to refactor a tiny chatbot we started a few episodes ago that helps outdoor enthusiasts find great trails to hike. Like last time, our chatbot only understands one command, view hike. Most of the time, this command replies with details about the hike, but when users ask for a hike that isn't in the database or their syntax is a bit off, the view hike function will throw a custom exception like a not found error or a validation error. In either case, the chatbot shouldn't blow up and stop running, so we started by wrapping a try-catch statement around the problematic code. But we quickly realized that every use of try-catch takes a substantial amount of boilerplate to keep from introducing a catch-all bug. To make sure we only rescued a particular error type, we introduced a simple utility called rescue, a guard clause which rethrows the error if the type differs from what we intended to catch. The problem with rescue is it only helps us catch one type of error at a time. So how do we handle both a not found error and validation error? We could make the rescue function accept multiple error types, but then we couldn't customize the fallback message based on the error type. So do we have to give up the rescue utility altogether and go back to cascading if-else statements to uniquely handle those different error types? Maybe not if we refactor a little further. Our remaining try-catch boilerplate is starting to turn into an obvious pattern. If we were to reuse this try-catch in another part of the codebase, all that changes is the function to invoke, what type of error to rescue, and what to return if there is an error. Let's extract this formula into a function called swallow, which takes an error type to swallow, a fallback function, and a function that will potentially throw an error. Now we'll use swallow to create a new version of viewhike that is safe from not found errors. It seems to work as before, but this code is still pretty verbose, and some might argue it's more cryptic than simply writing if-else statements. Well, if we just change the signature of swallow a bit to take advantage of currying, we can eliminate a lot of the extra function calls and argument gathering. Whoa, look at swallow now. It's a higher order function. It takes in an unsafe function that throws a particular kind of error, and it returns a safe version of the function. Because swallow returns a function that is safe from the not found error type, there's no reason we can't pass that function into swallow again to make it safe from a validation error too. That nesting is a bit nasty, but this is just the sort of thing the compose utility is for. Instead of nesting swallows inside each other, we can list them out from top to bottom and feed the original view hike function at the very end. It works exactly the same way as manually feeding the results of each swallow into the other, but it's much easier to read and maintain. This style of creating functions without first gathering and passing around all their arguments is called point-free style, and it's a big part of what makes functional programming so elegant. It took us some time to arrive at this design, and many of the intermediate steps seemed a lot worse off than just using try-catch. But just like the enforcer pattern we covered in an earlier episode, the best way to combine behaviors is through composition. Rather than cascading if-else statements or trippy multiple error handling logic or experimental catch syntax, we handled two kinds of errors through composition. If you aren't already in love with function composition, hang tight until the next episode. We'll use error composition to put a functional twist on a popular object-oriented programming pattern called the null object pattern. Today, look for try-catch statements in your codebase and break down the parent function until you can replace the try-catch altogether with swallow. And if you need to handle multiple error types, just layer them with compose. That's it for today. You can get a transcript of today's episode and catch up on other ways to craft exceptional code at jonathanleemartin.com/TLDR. And if you want to keep leveling up your craft, don't forget to subscribe to the channel for more rapid codecasts on design patterns, refactoring, and development approaches.